Okay.
Go ahead.
Okay. So welcome everyone for attending the second online event of GBX Vietnam. And first of all, my name is Minh, and I am in charge of the development of GBX in the Vietnamese market going forward. And in today's event, the topic is about the new development in AI and deep learning. And I would like to introduce to you Professor Francis Chin, and he received the master's degree in both in the University of Toronto as well as the University of Princeton in the US. And later on, he received he's in charge of the department and computer science in Hong Kong University. And now he has retired and started his company in AI and machine learning and deep learning as well. And so today I'm very pleased to introduce our VIP speaker to us. And so that's from the speaker side, and also from GBX side. I would like to introduce to people who are new to GBX in Vietnam, Mr. Winston, who is a chairman of GBX, which has helped various business like single companies or big groups and business professional connect together globally. He's now based also in the US. So, but GBX has different location, people like myself and a large group of business professional across Hong Kong, China, US, and London and Singapore in about more than 10 different countries. Yeah, today very pleased to have you all with us to listen to Dr. Francis. Let's start with the main topic. Professor Francis, can you introduce a little bit about yourself for the people?
Okay, just say good morning to everyone, and good evening to those attending in the North America. And can I start now? Okay.
Yes.
Today I'm going to talk about some developments in AI, in particular deep learning. And I hope that in this maybe 1.5 hour talk, you will at least understand the basic deep learning concepts, okay? And also understand some application of these concepts. For example, computer vision, natural language processing, and also some large language model, for example, ChatGPT, Sora, etc. Okay, this is my goal, but let's try to do it. The first time we noticed about the AI is 2016. Okay, this is the Nature paper mentioned that the AI, okay, really beat, okay, Lee Sedol, professional Go player, for the first time. Okay, so this is about 7 years ago. Okay, you can see that AI computer beat it, and later on, the year after, he also beat, okay, Ke. Okay, this is the best player, Go player, and also in China. And in the win is not a marginal, it's 3-0, okay? Beaten, and then you can see that, okay, Ke was very disappointed after playing this game. And now AlphaGo Zero is having awarded 9-10, okay? Is a ranking of the Go. And after that, AlphaGo retired, okay? Now you can see that why this is a big deal. IBM, in fact, have developed a chess program called the Deep Blue in 1997, almost 20 or 30 years ago, okay? And it beat the grandmaster of the Russian, Gary Krabarov, okay? Why this is a big deal? First of all, you can see that Go and chess are different game. Okay, the board is larger, 19-19 compared to 8-8. And moreover, the rule of Go is more simple. Simple, that means you do have more possible moves. 361 versus only 28, okay? And so when you want to, the method of finding the good move, you have to go for a search tree. And that means when you got more possible, that means you have the more possibility to look in, okay? instead of looking at 28 moves, you have to look at 361. And moreover, the game is longer. A Go game usually 150 moves. So the depth will be will be much larger. Because of this, it's more complex. And I talked to the developer of the Deep Blue. He visited in Hong Kong. He said that it's impossible for that time, for that technology, okay, to beat Go. But now you can see that right now, we can beat Go, okay, computer program. In fact, Deep Blue was only designed to play chess, but AlphaGo is a more general. You can play different kind of game, and that's why this is advancement. Now you can see that right now you got search engine, okay. You can find dogs, okay. It's not easy. You can see dog have different posture, okay, but we can find it correctly, or for sure there's some mistakes. But in general, it's doing quite well. For example, dog and cat, you can find a cat and dog. If I want you to describe what is a dog, it's not easy. You go to a cat, it's not easy, but the computer can do it very well. Spam mails, okay, Bill Gates said that at about 20 years ago, spam mail is a problem, and he tried to stop it. He couldn't. In fact, he couldn't. Not until recently, in a few years, then it can solve it by deep learning. Recommended system, okay, the Netflix, okay, and also self-driving car, all this technology. More than that, machine learning, speech recognition, face recognition, robotic, ChatGPT, all this in this about the last several years is a big leap, okay, in the technology. All this depend on one technology, is deep learning. Okay, now I'm going to describe what is deep learning. The same breakthrough, okay, in technology. We look at the history of deep learning. 1950, that's almost more than half a century, 70 years ago, we have AI. That was by Alan Turing, okay? After 30 years, 1980, we start machine learning, okay? And then another 30 years until 2010, we start deep learning. Deep learning, the history is about 10 years, or right now maybe 14 years. But okay, now what is AI? Okay, AI is, you want the human intelligence exhibited by the machines. Okay, right now we're talking AI, but at that time the AI is rule-based. Okay, that means you got an input, you got an output. And the program, the AI is a hand design program. Okay, for example, I give you that time the AI is an expert system. Expert system is to make the decision for the human, or made by the human. Okay, like okay, the machine work like a human. I give you an example. For example, medical experts. Medical doctors are experts. Okay, because what they do is they look at, okay. Oh no, let me see. How come it's not working? Okay. For example, look at the symptom. You ask you, okay, do you have fever? Do you cough? Do you have sore throat, running nose? Will you have all these things, a headache, etc.? You can say that, oh, this is a flu. This is an expert. For sure, a medical doctor is more than that. He spent about many years to study medical theory and background, and then they give you treatments. Now, this is an expert system. The program is going to incorporate all this knowledge of medical doctor to make it work, okay? So medical doctor is what expert system at that time to exhibit intelligence, okay? Bank loan approval too. The bank loan, the banker will ask you, okay, you want to borrow money from my bank? What's the income? What's the gender? Are you married? What's your age? Do you own a property, etc., etc.? Okay, so based on these rules, they're going to give you results, okay? Now, Alan Turing, with you know about it. This is the father of computer science. With you saw the movie about imitation game. He's talking about him, okay? He said that instead of build or produce a program which simulates the adult mind, why don't we do one to simulate a child? You know that to simulate an adult mind, a lawyer, a medical doctor, a banker, they spend many years, okay, to learn. And you want to incorporate all the knowledge in the program to consider all situations is very difficult. But there are so many rules, so many exceptions, okay, and you have to change the program more and modify it. Then this is very difficult. How can you incorporate all the knowledge in a program? Okay, so what Alan Turing is that why we try not to build an expert program? Why won't we just build a brain, a children's brain, a child brain, and with the knowledge, with the ability of learning, then he can learn anything. Okay, you build a child's brain, okay, and then the program is just have the learning capacity. So we can learn banker's knowledge, he can learn medical doctor knowledge. With you try to teach him, okay, how to learn, okay. So learning basically is the basis of intelligence. Alan Turing mentioned that, and we say that we should start with a child brain, okay. We have and then everything can be learned. The intelligence can be learned, not inputted. So we have machine learning. How do you learn? You learn from the past data, okay, to make correct predictions. Let me look at this. This is about 7 years ago, okay. This is the Fortune magazine. It says that a computer is deciding what movie you are going to watch, okay. Basically, is AI is going to predict, okay, the opening weekend box office hot, okay. So what it says is the computer program is to predict, okay, what is the income from the movie, okay. This is the results. But how do you make sure that a movie is successful or not? Will this movie be popular? Then what you look at, I ask you, will this movie be popular? Probably you will ask, okay, I don't know, but what type of movie is that? Is that a romance movie, a violence, detective, cartoon, or what? Or animation? What language is that? Okay, Vietnamese or what? Okay, English or Chinese or Korean? You may ask, what are the actors? Actress, okay? What is the background? Oh, you ask all these questions. What's the length of the movie? Who is the director? Okay, and what's the showing time? Okay, the summertime or vacation? You got many questions. After that, you may figure out or guess what the income will be. So how can we guess? We look at the previous movie and the sales. Okay, so that movie under this situation have that kind of sale, and under this situation we got that kind of sales. We keep all this data, okay, and now the movie is not described by the name, but by these features, okay. From these features, okay, this is a romantic movie, and this is the Chinese movie, and the actor is what, and then from this and what time, all these parameters fit in. Okay, for example, Star Wars, you say that science fiction, English. Okay, the actor and the actress is modern, and this director, etc. Many features, and then you say that what's the income so far, how long you sold it, etc. So this is the model. In fact, what we want to have is, if I give you the movie data, okay, and this is unknown, okay, and I want to get the box offices. Now this is unknown. That means for this movie, I got this sales, and for M2, another movie, I got S2 sales. I want to find out this system, okay, which can predict the sales of all the movies, all these movies, the past movie. So I collect all the past data, okay. Now I don't know this system, but this is what I want to know, to learn, okay. From the training data, this is the past all data, and then I try to learn, and then build up a new machine. And from this new machine, then if you got a new movie come in, I can predict the box office. Okay, this is machine learning, okay. I want to learn this machine. So basically, this is unknown. Okay, the system is unknown, okay. But I have the training data, and I want to make this hypothetical machine. Then you may ask, okay, what is G? What is this machine? For sure, we don't know F. Okay, we know F will be done already. But what is G? G should be very similar, behave very similar to F. Okay, but what is G? Okay, G basically is, I'll give you an example. For example, I got a baby. I want to guess what the length of the baby, how tall is the baby. So what do? You collect the data. Okay, age 23 months old is about 80 cm. 17 months, 75. 28 months, 29 months, about 83. I got all these data. Each of these data from a baby. Okay, this baby. These are all data. I got many babies. And I measure the age and also measure the height. And then how can I guess? Okay, now I plot a graph. Oh, this is the age and this is the height. I plot it here. And then I try to what? Fit in a line. Make a line here. Okay, this is the model. I don't know the measure. And then I guess, okay, you're 25 months old. I guess it's 81 cm. That's my model. Okay, this is G, okay? But you may say that, oh, how can I, this is not very accurate, right? You can see that it's not very accurate, okay? Because you got error over there. How can you make it more accurate? Okay, within a classroom, then I can have interaction. But in a Zoom, maybe it's difficult, okay? But how can you make it more accurate? Then you need more data. What kind of data? You may ask, okay, what's the height of their parents? Are they tall or short? If they are tall, probably it will be what? Will be longer, or it will be taller, the baby. And I'll ask, what's the weight of the baby? The weight heavier, that will be taller. You may ask, okay, what is the weight, okay, or what the length of the baby when she or he was born? I got this information. If you born with a bigger baby, then you're probably taller. Okay, you may also ask more information, okay, about what about his sister or brothers? Do we have big sister or brother? What is their height, etc. Okay, is that male or female? It makes a difference. You can keep on asking, keeping more and more features, and then your prediction will be better and better. Okay, that is the model. But now the model is we have a line fitting here. So in our case, for movie, let's go back. We may say that, oh, it depends on the type of the movie, the language of the movie, or the actor. Each of them a different weighting on that thing. Okay, just like that's like the baby thing. You have different weighting. Okay, this is the 0.7 month plus the constant. Okay, so here I have different weighting for this parameter. Oh, for example, type of movie is very important. The actor is very important. The language may not be that much. So the weighting will be different. Okay, so this is a model. Okay, basically is what we want to learn when we say that, oh, what's the learning? The learning is to learn these parameters. Okay, learn this 3, 2.5, etc. We find out these numbers, then we learn, okay, the learning algorithm to learn the value of W's. Now, let's go back. Why we have a model like this? This is a real network. Okay, the model is inspired by biologists, okay, by our brain, okay, basically inspired by the real biology. Okay, this is a cell. You got sensor over here. Okay, every time you feel pain or some action, then you fire, okay, the cell, and the signal go to the next cell and keep on going until you get to simulate your brain. So the neural network is something like this. This is a neural network. Okay, you got input and you got a node here, and you got up to a certain threshold, we fire and go to the second level. So this is a neural network. Okay, you got summation over here, summing all the values, and this is the inputs, and each one of different weights. And then now this is give the formula. Okay, this weight times the inputs, etc. When you got certain value, then you fire and go to the next level. In this case, for example, oh, this is going to be the length of the movie, language of movie, this is the actor, and this is a movie, a type of movie. So you got different weights on each of these inputs. And then maybe if the eta, so you got a formula like this, okay? You learn this for sure. It's complicated, more features, then you got more complicated formula. The eta, you may say that, oh, you got different Johnny Depp, okay, Tom Hanks or Harrison Ford. Oh, they're different, okay. For example, Tom Hanks, you got 1, Johnny Depp is 0.9, Harry Ford is not so famous, 0.4, okay. So you put different weights on this eta too. So you got different levels, okay. Now this is a real network, okay. In fact, if you got complicated enough, it can model anything, okay. So let me look at it. This is the neural network. In fact, you got very deep. The deep neural network, okay, that's why I got deep learning. That means you got many of these neurons and many of these layers, okay. And then event, this is the input, for example, movie, and you got the output, okay. You got the output. Output will be the sales, okay. Now you want to build a model like this. This model is the neural network, okay. Is the how can we learn it? Now you can see how can we learn it, okay. Now, in fact, this model, I'll go back here. NVIDIA is making this chip, a computer chip, to make all this computation. And this is all matrix multiplication. You learn, you know matrix multiplication. So you got this layer over here like that. This is NVIDIA chip. Each one of them is a matrix multiplication. You keep on doing it, and that's why right now AI is so popular, because depending on this multi-layer deep neural networks, and that's why NVIDIA is so popular right now. So now we got the data. Movie 1, you to be get the sale 1. Movie 2 to be sale 2. So you put in your movie over here and calculate the sales. Okay, for sure, you input the movie and compute the sale for each one of them. Okay, and then you know that probably they are not right, because the model cannot give the right prediction. So what you do, you train the model. What do you mean to train the model? You want to make sure that if I give M1, the output of this neural network give S2 S1. M2 will give F2. Mn will give Sn. So I want to, how can I do? I adjust all these W's. I adjust these weights until I get the right answer. So what do? Is I compare S1 with my output. If not right, I adjust it. And then S2 again. I keep on going. Go back once to adjust the value so that it gives the right answer. Probably when you adjust it, you affect the others. But you keep on going many times, okay? You repeat it. Lots of data. With my model, can fit all this old data very well. Then when you got a new movie coming in, I can predict the sale. That is my model. That's the machine learning. The learning basically is to learn these weights, adjust these weights so that it gives the right answer, okay, for the past data. The more data you have, the more accurate my prediction will be. So you can see that machine learning is how to produce the output from the design features. I designed the features, I got the input, okay, and then this is learning. To map the feature to the outputs, and this is going to learn, okay. Now, this is machine learning. I'm too bad we cannot have interaction. I don't know whether I'm doing fine or not, okay. Am I okay with you all?
You're doing great. Just
okay,
very good, very good. Yeah.
Okay, I'll keep on going. Okay. Now, this is machine learning? It's classical. Now you may ask, this goes until 2010. Okay. Now, what is this is the application. For example, okay, the flat rental. I want to what? To predict my flat, how much is the rent. I look at the size, I look at the floor, what floor, is it high floor? What's the district? What's the age of your building? How many bedroom? How big, etc. After this, I can predict, okay, how much rent I could get, okay. For example, stock market, the same. I look at the economic data, the news, the interest rates, okay, the company's earning, etc. And then I can predict whether that stock will go up or down, okay. I make all the past data, okay? And then learn from the past data. If you got new data come in, I can predict. Weather, the same. You got many features. Look at the season. Is it summer season, what months, okay? Historic data, the wind, okay? The sunshine and etc. Then I can predict, okay, the weather. Now, let me look at how baby learn. Okay, how children learn. This is my grandson, okay? Okay. Right now he's about 5 years old. At that time, he's 1.5 years old. How we learn? Let me look at how human learn. The human does not learn like this. The human do not learn like this, okay? They learn the concepts from the raw data. Okay, for example, when I teach a child what is a dog or a cat, okay, I show him, this is the cat, this is the dog. Okay, you can feel it, okay? But the child will learn it. You don't, I mean, the mother doesn't have to tell him a cat has whiskers, has fur, has a tail, has 4 legs, 2 eyes. The parent does not need to identify the features. The baby look at it and capture it by themselves. Okay, so the human learn the conclusion from the raw data without going what is the feature, okay, about. Okay, now that is deep learning. Remember, when you look at a movie, we have to tell him what the feature we look at. But for deep learning, you don't have to. You learn from the raw data. Okay, this is the deep learning. Okay, now how can it do? So what you do is you got an input. You don't have to define the features. They will learn the feature themselves and learn the simple feature, complex feature, and get the complex and get the output. It's end to end. This is end to end. Okay, you learn the feature and learn the output end to end directly. Okay, let me give you some example of what the end to end. Sentiment analyzer. For example, you are holding a restaurant. You get comment from the customers. They say that the food is good and the service is excellent. Okay, then you say, oh, this is good. Okay, now we say that the place is dirty and noisy. Then this is negative. How do you analyze this thing? Machine learning is like this. You call a parser. Oh, I see the word good and excellent. Oh, I see the dog dirty and noisy. Oh, good and excellent is positive. Okay, dirty and noisy is negative. So you need this thing and you classify it. This is machine learning. Okay. So what about deep learning? What about deep learning? You just input and get the output. We don't have to tell him you have to look at the words good or excellent or service or like this, because you may have sometimes the food is not good and the service is not excellent. Okay, then this is negative. So this, you got so many rules. When you want to define like this, you got many situations. Okay, so but now deep learning, you don't have to. They learn it from the directly end to end. Okay, for example, automatic car drive. I give 2 examples. You look at the camera, or you look at you detect the car, you detect the partitions, and then you can prevent the partition and prevent the car and find an empty road to go, and then you steer your direction, the speed, and everything. You plan the graph of the path for the car. Okay, this is the old ways of doing it. Machine learning, deep learning, you get the camera and just tell you where you see and what speed you're going to have. This is deep learning. Okay, you don't have to plan. Okay, but now how this works, depending on which is better, depending on whether you have data. Here you need a lot of data in order to learn this. Okay, because you have the different situation, you got different way of steering. Okay, so depending on availability of the data. Now let me go back. How do we learn in school? This is school. The teacher asks questions, and the student raise hand to give answers. So this is called supervised learning. Okay. Now what is this? What is this? Car. The teacher teaches that thing. And what is this? Cat. Okay, that's all. Okay, and this chair and dog. So the machine, we are going to simulate this function, supervised learning. So this is label data because we have to give the answer for each of these labels. Now this is the neural network. We got many layers, complicated, many neurons, many connections. We got an input, and I want to say this is a bird. Okay, if I give an input a lady, then you will say that lady. Give a dog, then give a dog. I want, okay, to have this answer right. Okay, how do I do it? The data is like this. This is a cat, this is a car, this is a lady, and this is a dog. Okay, I put it here. It's just like the movie again. Okay, I learn. I want to make sure that if I give this picture in, I give this picture, the answer will be cat. I want to give this picture in, the answer will be car. How do they learn it? They learn it by themselves. And how can I learn it? I adjust the W, okay, so that it gives the right answer. Okay, for sure, there are many pictures. They got millions of pictures. And I want million pictures all give the right answer. Okay, I will tell you there's the competition on that thing. And the computer can do it well, okay? And that's why you need lots of data. The learning is to adjust the W so that for every picture you come in, I can get the right answer. Okay, I don't have to specify what you look at. Computer vision is difficult. For example, what is this? A cat. What is this? A cat. Okay, all these are cats. Okay, but it's difficult, right? You can see that. Now you can see that this is even a cat. Okay, it's disguised. Okay, and this is a cat. Now, how can the computer learn it? The computer learn it. Okay, you don't have to specify with the features. Even this one is also a cat. So computer vision is very difficult. Okay, but the computer right now can do very well. Okay, better than human. Okay, why this is a cat? Because the size, the scale, and everything. Okay, it's not a tiger. Okay, now let me look at how human works. Because what we learn is from the human. The human have developed million years, okay, of development. They must be doing very good, okay, because improving genetically or something like that. Okay, look at the eyes, okay. This is the eye, and you look at this person, okay, and now this is the person, a profile. You got neurons. The first time is to recognize all these edges, okay, and then later on you got a bigger, okay, bigger features. This is the eye. This is a Nobel Prize winner. Okay, they find out this, they discover this, and eventually up the end they can tell you, oh, this is a male and something like that, and this John or Mary. Okay, the eye, the human neuron is doing something like this. It's simple cells, it's processing. This is Nobel Prize winner. Okay, they discovered it in 1959. And then what about machine learning? Machine learning. The deep learning is similarly. You give a cat, you give layers. Here, only the pixels. Each pixel is black or white. What's the color? What's the how dark it is? And this detect the edges and primitive shapes, etc. At the end, they will give you tell you whether it's cat or man or something like this. Now, this is the what? Photo. And this is simple features, most complicated feature, and then you give the object. Okay, this is the output object name. Now, for example, this is a lady. Okay, in fact, this is Monroe. Monroe. Okay, so you can see that at the first layer only black and white, and now you got some more complicated feature. Now you can detect mouth, half the face, and then the whole face, and then will tell you this is the lady. Okay, now the computer look at it. They got many layers. How many layers? Thousands, millions. Okay, and many neurons. For example, you look at ChatGPT. You got trillions of this, of these neurons there, and it's complicated. I'll talk about that later on. Okay. Now, how can the deep learning affect the computer vision? Okay, the vision was done by rule-based, but right now it's getting more like this. Okay, let me tell you how this is done. First of all, you need data. Okay, because you want to teach the system to learn. This is the data. You got 15 million, okay, this is 2010, okay, about 14 years ago. They got a database. They built a database of 15 million images. All these images like this. And each image, they give a label to it, okay? For I cannot see it. For example, this is, I cannot see very well, okay? But some of this is a car, or for example, this is a car, okay? And this is a dog, okay? Or something like this, okay? So you collect all this data and got 3 years because you got 50 millions, okay? And many labels into what? 22 categories. This is a bird, a fish, a mammal, etc., and food, etc., and put in the database. Okay, this was done, take 3 years to get all these labels. How these labels, for example, okay, then you got a competition. Okay, this competition, annual competition for image classifier. They choose 1.2 million images and only have what? 1,000 categories. And each one, this picture, the computer can make 5 guesses. Okay, and then with one of them, for example, this one, the people label is a leopard. Okay, leopard, okay. So the computer give 5 answers. Leopard, jaguar, cheetah, snow cat, or even cat. If one of them is right, then it's correct. Okay, okay. The top 5 error, okay. For example, what is this? This is a whale, okay. So the computer give out 5 answers. One of them is a whale, yes. But with the computer give dolphin, bear, bird, car, train, no. So this is correct and this is not correct. So the computer is going to give many, or I didn't give examples. You got 15 million of these pictures. Sometimes it's very difficult, okay? Sometimes it's very difficult. You don't know what it is, okay? Because you can guess wrong, okay? Because the people will look at this differently, okay? So there's a company, because time is short, I didn't give you too much example. In 2012, okay, 2012, okay, 12, there's a competition. Every year you got a competition. The error rates usually about 25%. Okay, this is the error rate about 25%. And on that time, University of Toronto break the other competitor by a big margin. They are 25 or above, but here only 16.4. Okay, all the competitors, okay, for the past years, they are all, okay, 25% of the error rates. It's very difficult, but at that time, they beat it. Why you beat it? Because you use the deep learning technology, okay? So, in fact, you can see that before it's 28, 25 or something like this, but that year, it dropped, it improvement. The error improved to 16.4. Later on, they use the same technology, refine it. You got 11.7, 10, 7.3, 6.7, until you got 3.3. 3.3 is better than human. Okay, human try it, only 5.1. I didn't show you an example. It's very difficult, okay? Human may make a lot of mistakes, okay? Because you got a picture of, I don't have time, okay? Otherwise, you can see how difficult this competition. Why here can make mistake. After here, this competition stop. Because once they beat human, it's already done, just like the goal or like the AlphaGo, okay? They beat human, they retire, okay? So, but all these improvements are based on this refinement of the technology, deep learning. Okay, now you can see that the complexity of the model. You got 8 layers, 19 layers, 22 layers, 152 layers. That was about 8 years ago. Right now, you're talking about thousands or millions of layers, okay? They're more complicated. Now, this is my story about vision, okay? Now, let me go to let me see the time. Oh, this is over already. Oh, yeah, half gone, okay? So, right now, let me talk about natural language and machine learning, okay? And machine translation. I will describe why we want to talk about machine translation, okay? How they're related. Let me see. Now, this is the history of machine translation. The same chart of deep learning. You can see that. 1950, you have rule-based. You know what rule-based? machine translation. I'm talking about machine translation right now, okay? I will tell you why we want to talk about machine translation, because this is a core. Okay, even GPT is talking about machine translation, the transformer is translation. Okay, now let me talk about machine translation. You will see that how this is related to the natural language processing. This is a rule-based machine translation. For 30 years, they're using rule-based. And then here, you have what? Rule-based. And then another, this is statistical machine translation. Okay, like machine learning. Another 15 years, and then up to 2015. It's a few years later than vision. The vision later, and then you got rural, okay, machine translation. Okay, this is later on, these few years. Now you can see the chart. This is the performance of machine translation. When you have deep learning, you can see a big improvements, okay, on the what? On the machine translation, 2015, because using deep learning, okay. Now, the AlexNet, okay, the what? 2012, okay, is a vision. You can see the University of Toronto make a big through on that thing. And also here, AlphaGo, okay, 2016, 16, okay. So this is something in between, okay. Now let me see how machine translation works. Okay, I want to go to market today. Okay, what do you have to do the translation? You break it down into chunks. I want to go to the market today. Okay, then I want to do a translation model. This is a Vietnamese. Okay, I don't understand. Okay, before I use Chinese. Okay, but that because it's a Vietnamese people. So I think you can understand this is, I want to go to the market today. Okay, but this is not right. You can see that the order is not right. Okay, when you go to Google, the language model will say that, oh, the right way to be like this, the order like this. This is not the right order. So how do you do this? You add rules to make it flip around, okay, to make the right sentence, okay, and then more and more rules added. When the sentence is complicated, your translation to be correct, you got more rules, and that is the rule base, and it's not working very well because you have up to a limit, you cannot improve at all. Okay, now this is the rule base, the first 30 years. Now let me do by using statistics, the second phase. The same thing, you break into sentence into chunks. Now, in fact, I cheated. Each one of them have different translation. It's not only one. Okay, you can choose. I think if you are using Vietnamese, you understand, okay? To go have a different wording. One have a different wording, okay? And then I want, okay, sometimes it means I hope, okay, I need it or something like this, okay? So it's not easy to have one translation on that thing. So you generate, from this word, you generate all possible sentences. For example, I can use this one and this one and this one all coming up, but this is not a right sentence. I can try this one too, okay? I can try this one too. Even the orders may be different. I try all these possible sentences, but which is the right one? Which is the right one? I want the one what? The most common one. This is not common. Why? What do you mean not common? I haven't seen this thing at all. This is not a sentence. Okay. This is more common. I have seen this thing. Okay. That's why when we say common, you mean statistics. Okay. How do I do that? How do I do what is common? Okay. Now let's go to the language model. Oh, this is, I should have a language. This is, I think, I'm sorry, okay. This is an animation, okay. You look at it. A language model, you tell what is the language. Okay, for example, in previously, this is not in the language, but this is in the language. The language model, it basically is a probability model to tell you, for example, I love you is high. Turn off is low, because this is not in the language, okay? So I give you a word, W1, WN, the language model will tell me what's the probability of this. This is really a sentence in the language. How do I do it? I will talk about when I calculate the probability of this word combination. I look at the probability of W1 and look at the probability of W2 following W1. Okay, and then keep on the WN followed by follow the W1 to N minus 1. Okay, I want to get this probability, and this will give you the probability of the strain. Okay, so basically, oh, sorry. So where this is the probability of next word. Now you remember, ChatGPT only gives the next word. That is exactly the idea. What is the next words? Okay, when you given all those. Okay, there's the probability of the next word. Why is it like that? Because the probability language model. For example, I love. What's the next word? Okay, you calculate the probability. Can be you or cars or eating. It's all possible. But probably not is. I love is. I love not. It's not. The probability is low. Okay. So I calculate all these probabilities. Okay. For example, this is high. I love you. I love car. I love eating. Is high probabilities. Okay. But very low or even zero. Okay. I love not. I love zero. Okay. Well, how can I get the probabilities? This probability from the documents. I look at all these literatures. I never see this. I don't go into how do I calculate probability. You can guess, okay? From the document, from the website and everything, I know that we don't have a language like this. Now let me go to the natural language. 1970, we have rule base. All these are rule base, okay? And then later on, you said statistics, okay, which is got collection of data or documents, and we want the statistics. For example, spelling. You see, one of the things you learn about language is the spelling. Is this the right word? Yes, this is the right word. Is this the right word? Not sure. I don't know. I will check the dictionary, okay? But basically, this is not a word. Why is it not a word? You look at the dictionary coming from the word of a document too, because the probability is very low, is zero. Why zero? I look at all the documents. I never seen this word, okay? Then what about grammar? I go, he goes, one book, two books, two ship, no S. One water, it's not right. One water is zero. A drop of water, okay, or something like that, but no one water, okay? So the grammar, why I go, he goes, one book and two books and not two ships? Because this is a grammar like this. How do we learn it? Okay, how do we learn it? We learn it by grammar. We go to grammar school and remember all these spellings. We learn a man and a pen, all these spelling. We memorize this thing. And we are using rule base. If you look at a foreigner, okay, for example, Englishman, okay, ask him, okay, two ships, he know that he knows two ships. Why no one drop of water? He know that. He doesn't have to learn grammar. Okay, we learn grammar because we do not, it's a quick way to learn a language. But for the English person, Englishman, Britishman, or British US, they don't have to learn the grammar because they have seen a lot of these examples. And already is statistics. Okay, because why one book, two books? Oh, because it's natural. Okay, I've seen two books, no two books. Okay, he goes. Okay, I go and he goes. For us, we are learning by rule base. For them, they are using statistics. They haven't seen it, they already implant it. Okay, already learned it like this. What about structure? The same thing. Subject, verb, objects. We learn this thing, but for them, they learn it laterally by seeing a lot. What about style? What means style? Okay, everyone is style. This is formal writing. This is casual writing. This is style. Okay, for example, this is Shakespeare. Okay, this is you got to be or not to be. This is the question. Oh, this is Shakespeare style. Okay, how do I get this Shakespeare style? Okay, so I learned it from the Shakespeare work. I get all this Shakespeare work. I got a language model and come up with this paragraph. Okay, king rear. Oh, if you were a feeble sight. Now it sounds like Shakespeare's. But what's the meaning? I don't want to talk about meaning. I only want the style, okay, right now at this time. How to get it? Using statistics. What the next word is generated? King, rear. Oh, if you were, okay. All this by doing the language model, getting the next word, okay? But no meaning at this time, okay? So this is the style, okay? Now, exactly. I got W1 and WK minus 1. What is WK? Okay, now you can try it, your computer and a Bible, okay? You compute this, many computer books and the Bible, you get the next sentence, you can see the mixture of computer and Bible. The righteous to inherit the land and leave it as inheritance the child, God according to the number of steps. Now you computer science, okay? So the style, you got mixture, okay? You can generate something like this, okay? By using statistics. So now you know that how the language model, how can you get spelling, grammar, structure, style, all this from the language model, using statistics, okay, from document. What's the meaning? You know that without learning the word meaning, we can't go anywhere. Okay, how can we got ChatGPT? How can we do have all these things? Okay, how can we learn the meaning? Okay, what do you mean by learn the meaning? What do you mean by learn the meaning? Chinese, the words and the meaning. For example, this is sun, moon, because they look like a sun, okay? And this is 1, 2, 3. You can see that 1 is 1 stroke, 2 is 2 stroke. The meaning already captured in Chinese words, okay? But, okay, this is up, and this down, and this is sharp, okay? You can see that the Chinese word is good because the meaning is captured with the word. But what about here? What about go? How can you associate the meaning with go, G-O, okay? Or W-A-T-E-R? You cannot attach it. So this is not good English. In Chinese, you can capture meaning by the words, okay? So, in fact, how can we represent these words? We can use the numbers 0, 0, 1, 0. This capture a dog. But where's the meaning? You cannot see the meaning. Okay, now, in fact, we want the word to be captured by its representations. Okay, how can we capture by representations? For example, I want king, queen, prince. All these are words. Okay, I just give an example. Dress, sample, many of words. The vocabulary we have 100,000 of words. How can I describe the word? I want to represent these words to capture the meaning. So I can get, I have the feature of royalty. I have the feature of gender. I have the feature of wealth, age, or hair length, number of legs, many of that thing, color, or something like this. Many features. The king, royalty, almost 1. Okay, gender, this 1 and this is female, low. Wealth, very wealthy. Age, 74 or 75, okay. Nationality, British or something like that. Hair length, this is longer hair for the queen. Age, 2 legs. These are the features, okay. These are features. Prince, okay, I can do the same thing with the prince. Okay, prince is wealthy, but not too wealthy. Age is younger, okay, all 2 legs. And I can do this for the hand, no royalty. I can keep all this. Now, I want to represent these words with these features, just like a movie, okay? And then the cats, okay? For example, dress, no royalty, low legs, low hair length, okay? Sample, something to do with hair length because it's sample, okay? That's why point something like this. This is neutral. The cat has no royalty, okay? And here the dress is neutral, okay? So how I can learn this feature? I want to represent, okay, each word with these representations. And this representation will represent the words, okay? So this is called word vector. Each word will represent by a vector. It's a multi-dimensional thing. And each of these dimensions represent a particular feature of the word. Now you may ask, okay, how can I learn, how can I got this feature? How can I learn this? Okay, now remember the learning the word meaning is basically is to get this feature vector. Okay, so that they have all these features and the value over there. You may ask, how can I learn this? Deep learning tell you. Deep learning is to learn the what? I tell you, you have to learn both the feature and the corresponding values. Just like the move, the what? Remember, I don't have to tell him what the feature to look at. I want the computer to learn all these features and also learn these values for the king. Okay, this is deep learning. That means I want to represent these words with the same the what representation. How do we come up with the word embedding? This is the word embedding. This embedding represents this word. This represents the queen. Okay, with feature value by deep learning end to end. Okay, I don't have to tell him, but he will learn it by himself. Now this is similarity. Okay, now how do I do it? In fact, sometimes this is many years ago, they say that words in similar contexts have similar meanings. Sometimes we look at, okay, you should know a word by its company it keeps. Sometimes we look at a newspaper or a book. Sometimes some of the words we don't understand, but we can get the meaning. But look at its labels, look at the context. Oh, probably mean like this. The same thing here. We want to learn the meaning by the context. This is called the distributional hypothesis in linguistics. You already know it. The related words always appear in the same documents. For example, economic, money, finance, banks almost appear together. Dogs, cats, pets appear together. But money, dream, liver, north, they are unrelated. They seldom appear together. Okay, so how can we learn? How can we learn? The documents is our data. All documents. The document in the websites, in the books, in the literature, or everything. Okay, you're chatting. All documents because they are human made. Okay, and so you remember how we learn? We got input, output, right? And due to neural network. In fact, we have movie and sales. That's what we learn about the neural network. But right now, what we want to have is different. My cat sits on the map. My input is what? I want to guess the word by the surrounding context. Okay, basically is my cat, question mark on the map. What is this word? Okay, this is the model. Okay, this word can be what? Sit, set, sleep, cross, peace, jumps, or anything like that. Okay, but not iron, whale, north. Okay, many will not be fit in these possible words. So these are possible words. So my input is my sit on the map. My answer will be cat because my document is my cat. And then my cat on the map sits. This will be the answer, sits. My cat sits on the mat. Mat is the answer. So I want to train the network so that when I give this input, I will give the words out. The deep learning, this is, when I learn this thing, well, then I can guess, I can get a representation. And where's the document, many documents. All the documents can be my data. You remember in Vision, the image, we have 15 million pictures. Label it. It takes years, 3 years. But right now, for natural language, every document is the data. And they are unlimited because all these are handmade, human made, okay? Human write it, not random words. This is the data, okay? So that's what I got. I, cat, mat. 中文，我的猫, okay? And the output to be what? To be sit, okay? And I learned this thing. And here at the end, this is the word vector. This will represent the word sit. Okay, and why is it like this? Because this is supposed to be learning like this. Okay, so we got lots of data, books, documents, articles. You don't need human label effort, and that's why language label. You'll see later on how the ChatGPT how it works. Okay, okay. How do we know the embedding is good? Does it really have the meaning when I doing all these things? Now let us try it. For similar words, we find out that, for example, banana, mango, they are close together because they have similar meanings, okay? And apples, okay? And all these are what? High-tech company. Apple in between is not a fruit, it's not in a high-tech because you get Apple phone or something like that. Okay, so you can see that they do have similar meanings, okay? They have similar meaning. I eat an apple every day. He play an Apple phone. They're Apple, but they're two different meanings. Apple in all his eyes, okay? The word vector right now can to be dependent on the context. And that's why attention. Okay, later on I'll talk about attention or about the transformer, okay? Okay, in this case, you got the word vector, which is independent, okay? But usually to be look at the context, usually get the meaning. Also, you can see that work, walk, walking, swim, swimming. Okay, this past tense and the continuous tense. This direction means the tense. They got meaning. For example, country and capital. When they are related like this, these vectors are very similar. You know this vector, you know the vector is translational equivalent, okay? So they are all mean the same thing. What they mean is the country and capital, okay? Man and woman, okay? This is sex, okay? This is a man and woman. So this is a boy and girl. You can see that, okay? This pair of things are the relation related, okay? This is boy and girl, and this man and this with woman, okay? Similarly, okay, these are all similar. Waiter, waitress, cook, hand, king, queen, father. If I got here, I look at here, then you give me waitress. They have the meaning, okay? The word have similar, the vector. So even though you can Japan sushi, Vietnam is, I don't know, China dumpling, Mexico taco, they learn it, okay? Why they like this? When you look at the document, you train it, the word representation, look at the vector, they have this kind of relations. Okay, now let me go to the what? The translation. Before the translation, you got chunks and language model like this. But 2014, you got this paper is very differential. They call encoder and decoder model. The translation is doing like this. You got a word, you got word embedding, you got a state vector. He, okay, likes to eat. You go on this, each one of the word vector, and you combine it, and then you got a sentence embedding. And this embedding represents the sentence. Okay, this is the encoder. You encode the whole sentence by this embedding. Okay, and this word embedding. And how do you do the translation? Decoder, your first word. Okay, I don't know about the Vietnamese. And then using this word, and the next stage, you got generate another word, next word. Always come out the next word. And then go to the end. Okay, your next word, next word, next word. Okay, and this is decoder. You predict the next word, depending on the previous word and the sentence embedding. Okay, all these states. Okay, now this is encoder and decoder. And machine translation is doing like this. I want to go to market today. This is embedding, encoder, a number. How big the number? How many dimensions? When I'm using a 500 or something like that, right now is more than 10,000, okay, usually. For example, ChatGPT is 9,000 something, okay? So I call it, this is embedding. It's a vector, multi-dimension. These numbers capture the meaning of this sentence, representing the sentence. And then I use it decoding. I should be able to get the same sentence out if I use the English decoder. Okay, this is auto encoder. This is very important. Right now, I should be able to do this. Okay, now, if I use a Vietnamese decoder, then I got translation. Okay, if I use what? How can I train this? Pair data. This paired with this one. Okay, this paired with this one. Okay, so I need these all data. Okay, we need data for doing translation. Okay, and then I got pair data with Japanese too. I only use the decoder, okay? So this is Russian, French, Chinese, okay? All this is Google is doing that. That's why you can go to different languages. You have an embedding or input, and then you can go to different encoder and decoder model. Okay, now why we want to go to translation? In fact, this can go to chatbot too, automatic answering system. Let me look at it. The chatbot, the Google is the first one to use chatbot, the Google, because here the technical team have many questions and they want to answer it. For example, this is the employee questions. Here encode it. So we then encode this question. And when you decode it, it's not decoding the answer, it's decoding the answer, the response. Okay, this is a chatbot. It's an encoder and decoder too, using the same model. Okay, so this is a kind of translation. The translation is you got English, go to different language. But here, you got a question, you got the answer. It's a kind of translation too. You embed it and you decode it, okay? So, for example, I see an error related to VPN. And then you say that, what error message you get? Okay, this is decoder. It's like a translation. And then, similarly, picture caption. I give a picture. And then it will tell me a white cat and a young boy, a decoder, cat decoder. So this is the input or the encoding thing. So now let me see, what time are you? I think I don't think I can finish too much, okay? But am I doing all right? Okay. Am I doing all right so far?
Yeah.
Because it's already more than 1 hour already. So I go, okay. Maybe I'll go on, okay, a little bit. I don't think I can finish all the material, but I'll try to squeeze in. Okay.
Yeah. I think just the general overview is okay, because I think a lot of people here actually at first a lot of people from company like Intel and some of the semiconductor chips that they want to join, but today I think we still have some people in the AI field. So I think you can give us the
maybe too preliminary for, I don't know that the audience, okay, maybe too preliminary for the general audience, for the experts, okay. Okay. Yeah. But okay, I'm sorry, okay, because I don't know the background of the general audience, okay. So what is the embedding and generative? Okay, now you look at it. This is the vision, okay. This is, I didn't talk about convolutional neural network. Basically, you get a picture and eventually you got the answer out, okay. And this is at the end, this is fully connected. And this is the embedding. This is the embedding of the picture. And based on this thing, they are going to what? To tell you what the classification over here. Okay, this is the classification over here at the end. So let me see. Okay, so each item is represented by close together. So for example, a dog, there are many pictures of the dog, but the dog, the representation to be close together. Okay, so that is the meaning. That's why the similar meaning to be close together in the language model. Okay, so this is the category to be close together. Now, for example, look at this. At first, okay, in the long time ago, many years ago, the Chinese, the postal office of US, they try to use the character recognition to recognize all these numbers for the zip code. Okay, and so this is got 9 numbers. Okay, so they represent this thing, each number, each point here is a vector, is an encoding, and these are all ones. Okay, this is 0. Okay, because they are all close together. That's why when they come to here, they can see that this is 0, and this is 1, and this is 2. Okay, and this is etc. Okay, so when go a figure come in, they know where you will go into. Imagine this multi-dimension. Okay, now project 2 dimension. That's why they seem to overlap. But you go multi-dimension, they are to be very distinct. Okay, now what about this one? Now all these points is one data. Okay, but if I pick up one of these number here, which is not, okay, is not generated, but just a representation between 1 and 2, because you got 2 classes over here. I just pick a point over here. Then if I try to decode it, then it will be look like 1 and look like 2. It's just in the middle, okay? That is a generation, okay? For example, if I got a rock music, a classical music, I got something in between here. This is a representation. Then I got half rock and half music. If I got a face with glasses and face without glasses, then this represents glass, okay? So I can remove the people's glass, okay? By using from here to move back to here, then I can generate it. I got an encoder and decoder, then I can make the face without glass, okay? So for example, here, this is a man and this is a woman. You can see that in the representation, embedding. This is the man with glasses. Then what about here? This is the man without, this is the lady, the woman with glasses. Okay, then this is to be, many of them to be related. So you can see that I can generate pictures. Okay, by using, this is not the computer generated. I pick up a embedding here, and using the embedding, using decoder, again, I can generate different figures. So now let me talk about transformer and GPT. Okay, you know, G is generative. Now you know how to generate it. Generative is from an embedding. You go to decoder, and then you can get it. Okay, pre-train. This is generative. Generative is from encoding, and then you do decoder. Pre-train, I mean, train it already by using the data. Transformer is a type of neural network. Basically, you're doing translation, machine translation, okay? And using encoder and decoder model for the translation. This is a transformer, okay? And based on the paper at Google, attention is all you need. This is very influential papers, okay? Attention is all you need. But right now, the people, their research trying to do that. Why we have to use attention? Can we use other architecture? But this is very successful. We may have some different type of, we don't know, okay? Now, this is the what? Encoder. For example, translation, it like to use. When you go to decode, okay, you want to come out like this. You find out that when you decode these things, you have to pay attention to heat, okay, or something like this. So this is different. You have to, because when this is long, okay, when the sentence is very long, this number may not represent the sentence too well. Especially this sentence is varying. So the attention will add more information when you decode it. Okay, so this is not a fixed size anymore because the attention depending on the input size. So you pay different attentions, okay, on the previous word, okay. For example, this pay attention more to eat, okay, and this more or etc. Okay. So they at that time they pay different attention to inputs, okay. So the attention is you pay special attention to inputs, okay. Now, what is technology? Okay, for example, the ball, okay, you pay attention to blue and holding. Okay, the boy is a blue and also attention to the ball. So the attention, that means you can get the meaning, okay, better meaning out of this sentence. So, for example, when you got this thing, the boy, you can have what? Taste, love, likes, soccer. Now, because of this attention, the previous context, you know that probably is not hates, okay, more likely to be love or like, okay. When you say, that's why you're biased on the next word, okay. Otherwise, without the context, without this attention, probably then you can come out hate too, okay, or dislike, okay. But right now, because this attention, you can get better meaning, better prediction. Self-attention mechanism. For example, I eat an apple every day, okay. Then this is the word embedding, apple. Neutral. I don't know what apple means. Can be technical or fruit. If I eat an apple today, then I will what? I will get the attention to eat. Then I'll move, okay, to fruits. Okay. Then In fact, if I got a phone or paste, a phone, I play with Apple. I think I play a misspelling. Okay, I place. Okay, he plays. Okay, play. Okay, then in that case, it will be phone. By different attention, you can move your vector, okay, to different region, and you can get the next word better. Okay, so the multi-head attention is that there are many attentions. Okay, you got 1,000 attentions. Okay, so you can be adjective, action, relation, many, which I cannot name it out. Okay, and I don't, sometimes they don't have meanings, but they just get they learn it by themselves, the features. Okay, so this is multi-head attentions. Okay, for example, here, Russia have declared war on the US states after Donald Trump accidentally, what's the next word? The ChatGPT can do something like this. So what's the next word? Okay, okay, so can be, they give a probabilities. Okay, can be set, accidentally set, or press, or fire, or looked, or spoke, or end. Okay, this is a low probability. But higher probability can be what? Can be set. Okay, that's really set on something, or press something, or fire something. Okay, so the sum of the probability equal to 1. Okay, so this is already very high probability, or there are many words. Okay, some of them are 0. Okay, so all this thing, the model GPT-3 is the dimension 12K, more than 12K for each token. Okay, before is above a few hundred. Okay, and how to predict the next words? The same, Trump. Okay, so embedding. The Trump can be like this, and before the attention. Okay, by looking at the attention with Donald. Okay, he knows the U.S. president. Okay, so we get to the U.S. president region. Okay, and then Russian. Okay, or Russian is the enemy. Okay, so we got another region, a competing country. Okay, and then declare war. Okay, then we go to somewhere. Okay, because all these attentions will lead you to different region. Okay, and then the context. The longer the thing, the more precise the answer. Okay, right now, GPT can look at 2,000 words, okay, in the context, okay? So every version forget, the earlier versions, the GPT forget the longer conversation, okay? The longer the content it will be, okay? Then you will get the next word will be more predictable. Otherwise, you may get the wrong words, okay? Now, I want to general. In the ChatGPT, in the larger language model, there are 3 key components, okay? One is the model size, okay? The model, the parameters, and one is the data size, okay? And also the computation, the training, how much you train, okay? The more you train, the better you will be. But training is expensive too, okay? So most of the language model is undertrained. Why? Because the model is very big and the data is so many. You want, okay, the prediction of all the document right, you need a lot of training. So we found out that the LLM, the language model, improve with bigger model size, more data size, more data size, and more training. In fact, you can see that. This is the loss. Okay. You want more compute, the loss getting lower. Bigger data size, lower. More parameters, the model, lower. So they found out that if you increase all these things, the performance will keep on improving. In fact, that's why you look at the models, okay? The GPT 1, 2, 3, okay? This is the model size and performance, okay? GPT-2, they got 4 language model. They start with 117 mega parameters. They find out that they double it. The performance improves. They further double it. Oh, where's my mouse? Oh, they further double it, they improve. And they double it, they improve. They find out that the performance keep on improving when they double it, but there's a limitation of the size. They can double. Okay. So the performance improves, increasing the number of parameters, the model size. But the longer the training time and the same data sets, the data set is too many. Okay, you never overfit. You level over only underfit, okay, underfit the data. So, but there's a limit, okay, it's so expensive. That's why they found out, okay, the reading comprehension, the longer improve, this is the performance. Translation improve, okay, summarization improve, question and answer improve. They found out that the bigger the model, the better it would be. Okay, this is one observation. That's why it's still they want the bigger right now. Up to a point, that is called the emergent ability. Okay, this is something surprising. Okay, this is not present in the small model, but in the bigger model. Okay, you expect a bigger size, you got small improvement, but it's not. Up to a certain model size, the performance shoot up. For example, this arithmetic, this is transliterates, word unscramble, okay? Question and answer. You can see all this when the model get to a certain size, big enough, the performance trigger go up like this. And why is it like this? They don't know. We're still under research, okay? But they notice this phenomenon, okay? And that's why it's getting bigger and bigger, and that's why ChatGPT suddenly doing so good, okay? And the theory is still not known yet, okay? But everyone knows that now, okay? Just like, okay, I'll give you an example. The Wright brothers, 100 years ago, make a machine simulate a bird, okay? And can lift ground for about half a minute or 30 seconds or something like this. That was a breakthrough because no engine can lift the ground, okay, for stay in the air for half a minute. At that time, Wright brother built a machine can do that, okay. And when they find out that they make the aeroplane 2 wings or double deck or 3 wings or something like that. And the theory that they don't understand until years later, they got fluid mechanics. Right now, we understand how the aeroplane flies. But at that time, they don't know. The same over here. The people try to imitate the brain using neural networks. And suddenly, something happens. And they work miraculously well. But we don't understand. And there's a research going on. And probably after the next maybe 10 years, something like that, we understand better, then we can do better. But this is very similar, or very similar to what we had, okay, before in every research. Okay, now ChatGPT basically is a transformer using the embedding and decoder model. And based on GPT-3, is pre-trained with the data, okay? The size is, they reduce a little bit, the ChatGPT, because it's specialized purpose. GPT-3 is generalized, okay? But, so this is encoder, the input, and decoder. And they learn, okay, the meaning or the relation of the input words. They want a very precise description through the embedding size, which is about, not too big, about 15K. And then many attention heads, okay? And then they try to generate the fluent and coherent text, depending on the next model, next word, okay, a large model. You got lots of training data. In fact, there are too many training data and good input embed. This is ChatGPT. In fact, you can see that ChatGPT make 1 million users in 5 days. Okay, in 5 days, okay. And here, Netflix take many years. This is not exactly right because at that time, years ago, the internet is not so popular. Okay, so this is, but it's still a hit. Okay, on that thing. Okay, now TikTok invest doing quite well too. They got 100 million in 9 months. Okay, while is a big, in fact, ChatGPT and the Google AlphaGo is a big hit to the user. Okay, why is ChatGPT doing so well? Okay, I've been doing. I think I will finish it. Maybe I'll stop here. Okay, I'll finish this slide. Okay, ChatGPT is because you got powerful brain. Okay. This is the model, okay, large language model, okay, and you got lots of data, okay, more than we read. We got lots of drilling because of training, okay, and moreover, you have human coach too, because the human with human feedback, and that's why you're doing so well. Okay, I think I'll stop here right now to see whether you got any questions, okay? Because I think I've spent thank you very much for your attention for the past 90 minutes, okay?
Wow.
Okay, I pass it to the